So as we have already said in the earlier video of permutations 1, arrangement of people, arrangement of letters, arrangement of digits, it's all the same. Right? Generally the digits arrangement, you don't get a clue like which digits should be arranged. Sometimes they would give it as an extra condition. Normally what are the digits we see in numbers? 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the 10 digits that we can put in numbers. So let's say I'm trying to understand how many 3-digit numbers exist in the number system. So that means a 3-digit number will have 3 blanks, right? They should have 3 digits. So as I always said, let's look at the number of options available for each blank to find the total number of possibilities. So for the first blank, what are the number of possibilities available? Like these digits, right? I can put any one of these except 0. Why? I cannot start with 0. Whatever I put here, right? 099 is a 2-digit number, 99. That's not a 3-digit number. So a 3-digit number should not start with 0. It can start other than that with any other number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Anything is fine. So I have 9 options for this, right? Because I cannot put 0 as my starting digit, I cannot consider that to be an option. So leaving that, there are 9 options. Coming to this part, I can use any of these 10 digits, right? I can even have 0. Like I can have a number like starting with 2. Then I can have 0 and 0. 200 is a 3-digit number. Or 207 is a 3-digit number. So 307 is a 3-digit number. So yes, I can have any one of those 10 digits. So I can put any one from those 10. Again, for the last digit also I can put any one from the 10. So the number of 3-digit numbers is 900, which is true, right? The smallest 3-digit number is 100. The largest is 999, and these are basically 900 such numbers. So let's assume if the repetition is not allowed, like here I've counted that I can have 200, right? I can have 355. These are all counted. Let's assume if the question asks how many 3-digit number exists in the number system where all the 3 digits are different in the number. So again I start off with 3 blanks. In the first blank I cannot put 0. Leaving that I can put any one from the 9. When I come to second blank, how many options would I be left with? 9. Why? Whatever I select here, I cannot repeat it here because the 3 digits are supposed to be different. But it's not 8 because 0 was not counted here, but 0 should be counted here. Right? That's the point. Understand this again? So my first digit, if let's say it's 1 in my hundreds place, I cannot put 1 here. I cannot have 0 here because 0 is not a suitable number, a digit for the first blank. So I cannot put this, but 0 is counted here. So because 1 is used in my first blank, I cannot use 1 here. So all other options are accepted. So I have 9 options left. So I still have 9 options here. So 9 and 9. And now I will be left with 8 because I would have used 1 here and 1 here. I cannot repeat these two. So I will be left with 8. So the number of 3-digit numbers that does not have the digits repeated is 9 into 9 into 8, that's 81 into 8, that is 648, right? So what do I mean by that? The digits does not repeat is like I should not count like numbers like this where all the 3 digits are repeated. I should not count numbers like this where 2 of the 3 digits are repeated, right? If I remove all of this, I'll get 648 numbers where all the 3 digits are different in the number. So the remaining of these cases would be obviously 900 minus 648. So let's look at this question. How many 3-digit numbers are even numbers? So again I start off with 3 blanks. Even numbers, the only thing I need to worry about is the last digit, right? Last digit should be 0, 2, 4, 6 and 8. So how many options I do have in this last blank? 5. I'm doing it, repetition is allowed, okay? That means the digits, that's why it says 3-digit numbers, right? So a number like 242 is a 3-digit number and it's an even number. So digits are repeated, it's counted. Unless the specifically condition saying if it's just numbers, yes, the repetition is allowed by default. So I have 5 options here. I can put 0 or 2 or 4 or 6 or 8 here. I can put any 9 options out of the 10. I cannot use 0 here. So leaving that, I can use any one of those. And then what is the thing I'm left with? I can put any 10 here. So it's 9 into 10 into 5 is the answer. That is 450 even numbers. Which is easy, right? 900 is the total number of 3-digit numbers. Half of them have to be even, the other half will be odd. That's what it is. So how many different 5-digit numbers can be formed by arranging digits of 1, 1, 2, 1, 1? You see, this is like how the repetition of digits matter. Right? If I have number like 121, what all can I do? This is 1, 211 is 1, 112 is this. That's it, right? I cannot do anything else. I mean, if I even swap these two, I get 211 only. I swap these two, I get 211. I swap these two, I get again 121, which is what we seen in the earlier alphabet situation also, right? Ape gave me 6 different words. App only gave me 3 because these 2 letters are repeating. That's what we see here also. Same similar thing. I have 5 blanks. So 1, 2, 3, 4, 5. That's 5 factorial ways. By 1 is repeating 4 times, so I just need to divide by 4 factorial. That's why I'll get only 5 different 5-digit numbers. Right? They look like this: 2, 1, 1, 1, 1, 1, 2, 1, 1, 1, 1, 1, 2, 1, 1, 1, 1, 1, 2, 1, 1, 1, 1, 1, 2. Right? All of this, the same things. Similarly, this also 1, 2, 3, 4, 5 different digits, but in that 1 is repeating twice, 3 is repeating twice, sorry, and 2 is occurring once, so I just need to do this. So 5 factorial by 2 factorial into 2 factorial is 5 into 4 into 3 by 2. So 30 different ways I can arrange this to get different 5-digit numbers. This is exactly same as the alphabets, you know, what we did. Like if I have a word like apple, what should I do, etc. Same as just 1, 2, 3, 3, 1. Treat them as alphabets and do it. What you've done till now in this is like using the rule or logic of base 9 digits, 10 digits and repeating, non-repeating. This one is as simple as just the alphabets.